amount of mass per unit volume.
Okay. Hamza, okay, good. What about Aruba?
Same.
Same to same, sir. Same answer. Okay, very good. Very smart. Right? So yeah, it's the amount of matter per unit volume that Hamza said. Okay. That's close. Okay. So let's begin with the idea of density, right? So let me just first of all skim the content, then I will add on the details. Okay. And you had homework assigned. Hamza, आप homework Monday को देंगे?
सर पता नहीं मेरे को आज आज भी गया हुआ था अभी भी आया हूँ
हाँ,
5-4 बजे।
I'll basically talk with your mother, तो she said कि आप मंडे को दे देंगे, ठीक है? तो मंडे तक ट्यूसडे तक कर लीजिएगा आप, ओके? Ryan, where's your homework? Hello, Ryan. Am I audible? I guess Ryan is connecting some earphones वगैरह. So till then, let's continue, ठीक है? Let me just choose a color. So in everyday language, let's imagine lead. So what is lead? Anyone? Where do you find the term lead?
The predictable.
Yeah, lead is basically found in pencil, right? If you just recall, if you have a pencil, this basically the central black part of the pencil is basically made up of lead, right? So which basically helps you write with a dark A or B4 pencil, right? So this is basically made up of lead. So is lead is one of the elements in periodic table. So it is saying that lead is said to be heavier than wood, right? So can you think of a reason? Okay, why is lead heavier than wood? Why is lead heavier than wood?
Sir, it's denser.
It is denser, right? So what do you mean by denser? Raise your hand and answer. Yeah.
Sir, it has more mass per unit volume.
Okay. ठीक है. Anyone else wants to participate? Okay. No one. ठीक है. ठीक है. I guess everyone agrees with Ryan. So Ryan is saying that sir, it has more per mass per unit volume. ठीक है. So yeah, Ryan saw the formula and he basically manipulated the formula कि अगर sir numerator ज़्यादा बड़ा होगा तो overall answer भी basically would be great, right? Yes, Hamza, you want to add on? Okay. I guess I'm just thinking right now. So what does this term means basically? So as a layman, you would think by this it meant कि कुछ certain part of volume of lead is heavier than the same volume of wood, right? Imagine कि this is let's imagine this is the block A. It is made up of lead, right? And it is the same dimension, right? Let me just keep the dimension same. So we have the same dimension of the wood, approximately same कर लेते हैं, and it is made up of wood, right? So this layman statement says, okay, let's imagine that this section of the wood of the lead is heavier than this section of the wood, right? So it makes the overall answer, the overall uh basically lead to be heavier than. It says that lead is heavier than wood, right? Okay. So in science, such comparison is basically used using a term called density, right? So we don't just say okay, we just don't use these layman definitions. We need to be basically specific. Okay, what are we talking about? So the term which we are looking for here is one that is called density, right? We compare two elements, two components, or two blocks of same dimension with the term using density, right? So what is density? As Ayan said, K, sir, and Hamza said, K, and also Rupa said, K, sir, density is mass per unit volume, right? If a question comes in your theory exam, K, for the 1 mark, what is density? So just remember the formula. K, what is the formula? That is mass per unit volume. And thus convert the formula into definition, and it says K, it is mass per unit volume, right? Is it clear now?
Yes.
ठीक है. You can give me a thumbs up, ठीक है, जल्दी. Whenever I ask, is it clear? Just give me a thumbs up, right? Okay. So yeah, Diane gives me a thumbs up. Hamza, Rupa. Okay, good. So this is pretty quick to just ask a question and get a response, right? अच्छा जी. Let me just give you an overall estimate कि हम क्या बात करना चाह रहे हैं, right? if I just use my Picasso skills, let me just show off my skills. Let me insert a blank slide. Yeah, imagine that you have a 3D cube, right? You have a 3D cube. Imagine it contains liquid, right? So liquid के अंदर particles are basically slightly away from each other. ठीक है? Right? And if I talk about a gas particle, right? Let's say this is cube A contains liquid, right? And if I make a cube B of approximately same dimension, just give me a second, I'm getting a call. Just give me just 2 seconds. Okay, so apologies. Okay, so now we have a cube B which now contains a gas particle, right? Let me just draw the gas particles. You know, gas particles are pretty far away from each other, right? This is cube B which contains gas particle, right? Acha, dimensions are same, right? If it is length L, so this is also L, this is also L. Similarly, it's a cube, right? So can you tell me, can you just judge these two cubes over here and tell me which density is greater? Which blocks density, cubes density will be greater and why? Think about the formula. The formula says K density equals to mass per unit volume, right? Now think about this formula and see these particular two cubes over here and raise your hand if you want to answer, right? I'm going to give you a minute to think about it. Okay. Density of what X is greater than density of Y and why? You can guess also. It does not need to be correct.
Like, can you repeat the question?
I'm just saying कि if you just see these two cubes over here, ठीक है, liquid में you know कि we have more particles per unit volume, right? Because they are closer to each other, ठीक है. And दूसरे क्यूब के अंदर मैंने एक गैस को फिल कर दिया, राइट? तो जो कंटेनर है उसकी वॉल्यूम सेम है, राइट? सो इसकी जो वॉल्यूम है वी है, इसकी भी वॉल्यूम वी है, राइट? नाउ सीइंग द डायग्राम, सीइंग द नंबर ऑफ पार्टिकल्स, how what can you say about density? Okay, what density, which cube's density is greater than which cube's density? Let's say density x is greater than density y, right? तो अगर जो आप बता रहे कि लेट्स से a की ज्यादा होगी b से, क्यों?
सर इसलिए क्योंकि लिक्विड के पार्टिकल्स गैस के पार्टिकल से रिलेटिवली ज्यादा क्लोजली पैक्ड होते हैं।
तो उससे क्या हो रहा है?
उससे कॉन्सेंट्रेशन ज्यादा होती है।
कॉन्सेंट्रेशन मतलब यू आर सेइंग वॉल्यूम ज्यादा हो जाएगी?
बट
ये वॉल्यूम ज्यादा है, मतलब कॉन्सेंट्रेशन रेफर्स टू वॉल्यूम।
पता नहीं।
वॉल्यूम तो सेम है ना, ऐसा ओवर हियर कि वॉल्यूम इज सेम। कुछ दो कंटेनर फुली फुली फिल्ड हो गए हमारे पास, वो लिक्विड्स और गैस। अरे आई वांट टू आंसर, यस सर।
Sir, the mass in cube A is more, so there will be more mass because the volumes are same. So there will be more mass getting divided by the same
गुड,
volume, so that
गुड, गुड, आई होप इट मेक्स सेंस टू एवरीवन कि व्हाट इज रैन ट्राइंग टू से. सो आंसर इज बेसिकली डेंसिटी ऑफ ए इज ग्रेटर देन डेंसिटी ऑफ बी. व्हाई? बिकॉज वॉल्यूम तो दोनों की सेम है ना, कंटेनर के डायमेंशन सेम है, तो दोनों फुली फिल्ड हो गए. तो उनकी वॉल्यूम तो सेम है, राइट? So you can see कि there are more number of particles here, right? So what is happening over here? So number of particles, or you can say number of particles slash amount of matter in A is greater than everything to be defined on the left side by B, right? So if you just recall the definition of mass, mass is what? The amount of matter in a body, right? Mass is basically equal to amount of matter in a body, right? So if you closely observe the formula, and if I just again go to the blank slide, so the formula says K density equals to mass upon volume, right? Okay. Now see this example. If I have 4 upon 5, okay, and if I basically increase the numerator, let's say मैं इसको कर दिया 5 upon 5, अब मैं इसको कर दिया 6 upon 5, ठीक है, अब इसको मैंने कर दिया 8 upon 5, ठीक है. So I'm basically doing what? I'm increasing the numerator, right? So numerator is basically increasing. So what is happening to the answer? Overall answer. This is basically 0.8 in decimal points. This is 1. This is what? 1.2. And this is 1.4, right? Make sense? 1.5, sorry. 5, 6, 30. 5, 4, 20. 1.4. You can see if I increase the numerator. So what is happening over here? If I increase the mass, so the density is also increasing, right? Why? Because if you see the formula is saying that density is directly proportional to mass, right? So if I increase the mass, the density shall also increase, right? So that is the reason कि if you just see this example over here, so liquid की density ज़्यादा क्यों होती है gas से? This is the reason. If it makes sense to all of you, kindly raise your thumbs. Give me a thumbs up, everyone, if it makes sense. Okay, makes sense to Hamza, Rayan, Ruba, and Mashal is, I guess, still lost. Okay, Mashal, you can join us on the next slide, and you can watch the recording still here, right? Okay, okay. So let's continue. I guess now you have an idea about density, right? So what are we thinking about over here? We are talking about mass, we're talking about volume, right? And these two combinations give us density, right? Okay. So introduction, let's talk about some introduction over here, and let's see what are we talking about, right? Okay. So can you just read this slide for 30 seconds, and I'm gonna ask questions from you guys. What is written over here? And what are you talking about over here? Yes, who wants to answer? Just give me a brief summary of what is in this slide. Yes, Rayan, क्या बता रहे हैं?
Sir, they're telling us that the density of lead is 11 grams per cubic centimeter,
Mm-hmm.
which means that one if we have a piece of lead of volume 1 centimeter cube, that piece of lead will have mass 11 grams. And if we have a piece of lead of volume, for example, 6 centimeter cube,
Mm-hmm.
it would be 66 grams.
Okay, okay, ठीक है.
So this shows us if the density of a substance is known, the mass of any volume of it can be calculated.
Okay, okay, good overall. ठीक है, सही है. So let's they are talking about an example over here, right? So there's just give you an example कि how does the density basically is unaffected by the dimension, right? So let's see over here कि हो क्या रहा है, right? So they are saying the density of lead is basically 11 gram per centimeter cube, right? That is basically this. And this means that a piece of lead if it occupies the volume of 1 centimeter cube, they are saying density is equals to basically what? 11 gram per centimeter cube, right? Okay. So अब मुझे बताएं कि अगर हमारे पास इतनी डेंसिटी दी हुई, if I have a volume of 2 centimeter cube, let's say, so what would be the mass then? Give me a rough answer, a close estimate.
22.
Okay, anyone else?
22.
Yeah, sir, 22.
Okay, guys. अच्छा जी. So yeah, 72 क्या कह रहा है हमजा? Is it correct? Guys, you agree with Hamza? Hamza is saying 72. Okay. Even
No, sir, it should be 22 grams.
22
Like,
gram. Yeah.
2 centimeter cube should be 22 grams. That's
Yeah,
it.
Rupa is correct, right? Rupa is correct. This was just a introduction की जो हमारे नेक्स्ट स्लाइड में फॉर्मूले के बारे में बात करेंगे हम लोग, तो उसमें क्या आने वाला है, राइट? So I just wanted to test you guys. So yeah, Rupa has won the race over here. So you're given the density over here, the density of lead, right? The density of lead is 11 gram per centimeter cube, right? Up, let's say if I give you a question and you know the formula, right? You know this formula, K density equals to mass upon volume. Okay. And you are given the density, and if I give you the volume, you can find the mass easily, right? So Rupa ने just formula के अंदर इसको put in किया and she got the answer to 22, right? So that's what they are saying over here, कि the 1 centimeter cube has a mass of 11 gram. So if the volume becomes 5 centimeter cube, it's going to be 55 grams, right? It makes sense, right? Let's imagine this is a lead cube. This is a volume of 1 centimeter cube, right? So it has a mass of 11 grams, right? If I make the volume to be 5 centimeter cube, so now it has again more number of metals, more amount of particles inside this. Therefore, the mass is going to increase and it's going to be basically what? 55 grams. Okay, that is what they're trying to relate. So they're trying to relate these quantities. So how do they relate, right? So if the density of a substance is known, the mass of any volume can be basically calculated using this formula. We know that. Okay, so that is why engineers and all the scientists need a formula to work out everything, right? Imagine you're making a building, right? Let's say Rupa is making a building, right? Building बना रही है, कोई नहीं. And let's say it is a 11-story building, right? Let's say she wants to make a 11-story building, right? And 11 story means it has going to have how many roofs? 12 roofs, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So, this is the base over here. So, imagine what material is she going to use? Density. Or basically, she's going to refer to density, right? So, Rupa, let's imagine you're given copper, right? You're given copper options. You're given options copper, silver, and let's say aluminum, right? So this is the material available for the rods, for the material which can be used to create the structure, right? Copper has a density, let's say it has a density of, let's say, 3,300 kilogram per meter cube. Let's say this is the density. And let's say silver has a density of 1100. It's a rough estimated values, okay? Not exact. I'm giving example over here. Let's say aluminum has a density of 800 kilogram per meter cube. So which material is most suitable for a strong structure of the building? Ruba? Ruba. Yeah.
I think
Copper.
Yeah, because you want the building to be strong, right? So it's
Yes.
just an example over here. Okay, they are not exact values. So yeah. So obviously for you can see density, right? Density जितनी ज़्यादा होगी, it means that the structure is more rigid. It has more number of particles inside that. Imagine this is the rod which you're going to use, right, for the structure. So it is going to be pretty rigid, right? The atoms inside this particular rod is going to have a lot of matter in it, okay, and it is going to be providing a strong structure for the entire building to stand on it. Okay, so similarly, they are just saying that if you want to design any bridge, any building, any structure which needs metal, so they're going to basically analyze the density, right? And using the density, they design everything, right? So whenever you go out, you see copper wires, right? You see wires around you for carrying out electricity. ठीक है, so whenever you want to design any wire also, so उसकी भी आप density देखती हैं and different other parameters, right? So this is a pretty important factor in basically designing any structure or anything which requires material to be used that are basically in your periodic table, right? Which requires strength and tensile strength, so on and so forth, right? The strong enough foundations can be made. The SI unit of density is kilogram per cubic meter, right? We're gonna derive them in a while. कि कैसे आता है, ठीक है? So let's derive the SI unit of density, right? So we know the formula of density. What is density? Density is mass per unit volume, ठीक है? Imagine we are talking about a cube over here, right? Cube. It has dimensions length by length by length, right? Okay. So now let's derive the units. So we have seen in the first chapter, what is the base unit of mass? What is the base unit of mass? What is the SI unit of mass? ये मुश्किल सवाल तो नहीं है इतना.
किलोग्राम.
Yeah, it's
किलोग्राम.
kilogram, right? It's kilograms. You should not be thinking on this question. It's kilograms kg, right? What about the volume? Let's say volume कैसे आती है क्यूब की? Volume is basically going to be length by length, right? So volume is L cube of a cube, right? So what is the SI unit of volume? So seeing the formula on the right.
Sir, centimeter cube.
How do we measure mass? How do we measure length? Length is measured in meters. Hello guys, welcome back to Earth. Okay, length is always measured in meters. सही है. So we have the volume to be in meter cube, right? Does that make sense? Okay, so that is called cubic meter. Yeah. So if we just put in these things into the formula, therefore, this means therefore, it's a mathematical term. Okay, so density SI unit is kilogram per meter cube, right? Or if you want to write in terms of English alphabetical form, that is going to be kilogram cubic meter, right? Okay, I hope it makes sense. If is the derivation clear, keep me a thumbs up if it is clear. Okay, Ruba, Rayan clear है and मशाल को भी clear है. That's good. That's good. ठीक है. Okay. So conversion, right? So we can have different representation of densities also, as you guys said, K centimeter cube, right? So we can have density in basically we have density in kilogram per meter cube, but some values can also be given in gram per centimeter cube, right? So how do we convert? Let's say, how do we convert from gram per centimeter cube? Let me just first of all start with a simple case. First case is how do we convert from kilogram per meter cube to gram per centimeter cube, right? We have the relation that 1 gram per centimeter cube is equals to 1000 kilogram per meter cube, right? We're going to derive that from the कैसे होता है, ठीक है? अच्छा जी. So we have, I'm going to basically just solve the left hand side, right? I'm solving the left hand side of this relation of this equation. So we have 1 kilogram per 1 meter cube, right? 1 meter cube, ठीक है जी. अब we know कि what is kilo, right? Kilo stands for 10 to the power 3. We had seen this in chapter 1, right? Kilo is 1000. And how do we convert from meter to centimeter, right? So 1 meter is 100 centimeters. If I want to find what is 1 meter cube, I can cube both the sides, right? I can cube both the sides. So that is going to give me 1 meter cube is 1 cube is 1 and 100 cube is basically 1 million, right? It's 1 million, 6 zeros, centimeter cube, right? So in place of 1 meter cube, I can write basically these many centimeter cubes. And instead of kilo, I can write this basically relation, right? So I have this following basically simplification that 1 times 10 to the power 3 grams divided by 1 times 1 million centimeter cube. Okay. So if I simplify this, I can get the following relation that okay, जी. So it is equals to basically 0.001 gram per centimeter cube, right? Or I can say this as follows also. K 1 kilogram per meter cube equals to 0.001 gram per centimeter, right? So if I just convert the decimal point into fraction form, that is going to be as follows: that 1 kilogram per meter cube is equals to 1/1000 gram per centimeter cube. So if I want to basically, this is the relation from kilogram per meter cube to gram per centimeter cube. If I want to find relation from gram per centimeter cube to kilogram per meter cube, I can just make gram per centimeter cube subject, right? I can send this 1000 over here. So I will get a relation that 1 gram per centimeter cube is equals to 1000 kilogram per meter cube, right? So that's pretty simple. So we have two relations. But how do we go from kilogram per meter cube to gram per centimeter cube? And how do we go from gram per centimeter cube to kilogram per meter cube? Does that make sense? Okay. I hope it makes sense. If it
Still,
does,
I'm confused in this.
where are you lost?
Uh, Centimeter cube, like why has it written 1 meter cube is equals to 1, 2, 3, 4, 5, 6, seven
Okay.
zeros.
Yeah. It's 6 zeros, no? One, two,
No,
three,
sorry,
six.
6 zeros.
Yeah.
Six.
अच्छा. So basically, we know कि 1 meter की is equals to 100 centimeter, right? ये आपको याद है?
Yes.
ठीक है. So if I want to find 1 meter cube, so I just basically cubed both the sides, right? 1 का cube is 1, meter का cube is meter cube, right? What is 100 का cube is basically 1 million, right? And what is centimeter
Yes.
cube is centimeter cube. So this is a relation which basically tells you कि 1 meter cube is equals to how many centimeter cubes.
Okay, okay.
So मैंने किलोग्राम को मैंने ग्राम में कन्वर्ट कर दिया, मैंने मीटर क्यूब को सेंटीमीटर क्यूब में कन्वर्ट कर दिया, ठीक है. And therefore I had this answer, right? This is this relation over here.
Okay.
Does that make sense now?
Yes.
ठीक है. And then simply if I want to make gram per centimeter cube subject, I just send this 1000 over there, and I also have the relation to convert from gram per centimeter cube to kilogram per meter cube. ठीक है.
Okay.
So this can pop in your theory exam कि आपको वो डेंसिटी किलोग्राम पर सेंटीमीटर क्यूब में दी हुई है, बट आपकी मास इज इन किलोग्राम्स, राइट? So how would you basically manipulate the density into kilogram per meter cube? Make sense?
Yes.
ठीक है जी. So yeah, that's good. That's good. Let's move on. So these are some densities of some common substances which we found in Earth. ठीक है. So aluminium की I was close enough. ठीक है. So it's given in gram per centimeter cube, right? Solids की. So aluminum key is 2.7, copper key is 8.9, and then you can see copper has a very high density, right? I was pretty close. Iron has a density of 7.9 gram per centimeter cube. Gold has the highest density, but we cannot use gold to create building, right? It's pretty rare, right? And glass key is 2.5. You can see glass is pretty weaker than the copper, right? You can see the relation why. डेंसिटी इसकी बहुत कम होती है. वुड की सबसे कम डेंसिटी है, ठीक है. दैट मीन्स wood is pretty less dense as compared to other substances in this particular solid branch. Similarly, ice, right? You can break ice with your hands, with your bare hands, right? Polythene is basically plastic and it's pretty less dense too. Plastic can basically, if you just leave the plastic in air, which you should not, it basically fly in air, right? Because it is pretty less dense. So liquids के density we can see कि are less than or equal to solids. It's 0.8 paraffin, petrol 0.8, pure water is 1 ठीक है, gram per centimeter cube, and mercury is 13.6 gram per centimeter cube. Mercury is the only liquid which has a pretty high density, right? ठीक है. So mercury is pretty harmful material. It is used in thermometer, right? तो thermometer में जो देखते हैं ना आप, the gray particle, right? If you have a thermometer like this, right, and you have a tube, right, in the center, and a thermometer. This is called liquid in glass thermometer. And इसके अंदर जो आपके पास जो particle होता है, right, grayish particle. Let me just choose a gray color. Gray. You have a grayish basically particle inside this tube. This is mercury, right? And it is pretty dangerous if you just touch it, or if any particle goes into your body, it's poison, right? So don't try that home. ठीक है, सब mercury में try करूंगा. That is pretty poisonous, right? Okay. So similarly, air, hydrogen, carbon dioxide. So you should have a rough idea, right? कि mercury में liquid की सबसे ज़्यादा density होती है, ठीक है? If MCQs pops in your exam and you have a comparison between mercury and copper, आपके exam में copper सबसे ज़्यादा dense होता है. So that would be wrong, right? So you should have a rough estimate of values. Okay. So let's see which variable we use to write down in the formula for calculations and what does each term represent, right? You see that density is equals to mass upon volume, right? So it has three terms over here. The first one is called rho, right? It's a Greek symbol and it basically represents density, right? And then you have m, small m, right? It basically represents, sorry, let me just make an arrow. It represents basically mass, right? And then you have capital V. It represents basically volume, right? So density is basically measured in kilogram per meter cube, and mass is measured in kilograms. Volume is measured in meter cube, right? Okay. So let's say if I ask you guys to calculate. So yeah. So I was just saying, okay, what does each symbol represents over here, and up. Let's say if I ask you guys to calculate mass, right? And let's say if I ask you guys to calculate volume, so how would you manipulate the formula, right? So let's see for case one. So if I ask you guys to basically measure mass, okay? So you know density is equals to mass upon volume, right? And how can you make mass subject? You have volume in the denominator, you want to send it over there. So you're going to multiply it. So mass is going to basically equals to mass density times volume, right? If I ask you guys to measure volume, how do you measure volume? Okay, so I use the formula to manipulate and get V subject, right? So if you have density equals to mass upon volume, how do you get volume subject? Just swap density with volume, right? So you're gonna get volume equals to mass upon density. So there's a shortcut to remember the formula. That is called the triangle method. जो हम पहले कर चुके हैं for speed and displacement also. Imagine you have a triangle. Oh my God, a triangle is not a good one. Okay, let me just try to draw a good one. Right? So you have the formula density equals to mass upon volume, right? So we have mass over here, volume over here, density over here, right? So any quantity which is basically going to be up and down, that is going to be dividing, and if any quantity which are basically side by side, going to multiply it. If I want to find mass, so mass is going to be basically, you can see density and volume are side by side, right? It's density times volume, right? If I want to find uh volume, what is going to be the formula? If I want to find let's say density, what is going to be the formula? मुझे रुपए बताएंगी for a second and Masha for a third one.
So density equals to mass upon volume.
And volume is equals to mass upon density.
Yeah, okay, good. So that is a shortcut to remember. Okay, so volume is going to be mass upon density, and the density is going to be mass upon volume, right? Which basically matches the exact thing over here, right? So if you are not good at remembering formulas, just remember the triangle. That would help you out in solving questions, right? Okay, so let's move on. Any questions till now? If it is clear,
No.
thumbs up, thumbs up, thumbs up. Chilli sir. I want you guys to use the tools of Zoom available, right? Okay, good. Okay. So a question for you guys, right? Chilli sir, take out your pencil and copy and calculators and start solving this question. Hurry up. I'm gonna give you 2 minutes to solve. Okay? So first of all, when are you solving a question, हमेशा start के अंदर write down what is given to you, right? What data is given to you. ठीक है? So given the density of copper. So given the density of copper, ठीक है? That is 9 gram per centimeter cube. So in part A, वो कह रहा है कि अगर आपको वॉल्यूम दी हुई है कॉपर की, that is 5 centimeter cube, what would be the mass of the copper, right? So write down data like this. और जल्दी से मुझे I'm gonna give you 2 minutes to solve both the parts. So it's pretty simple, right? So if you don't remember the formula, just remember कि density equals to mass upon volume, right? So you want to just manipulate this formula for solving for the quantity side. आपको पहले में मास फाइंड करनी है, आपको डेंसिटी दी हुई है, आपको वॉल्यूम दी हुई है, राइट? हाउ डू मेक मास सब्जेक्ट? Just get basically volume on the left hand side, that is going to be density times volume, right? अच्छा, यहाँ पे देखें आपकी डेंसिटी भी ग्राम पर सेंटीमीटर क्यूब में है, आपकी वॉल्यूम भी सेंटीमीटर क्यूब में है, राइट? तो इट मीन्स कि आपका मास वुड बी इन ग्राम्स, ठीक है? अगर आपको डेंसिटी दी हुई होती किलोग्राम पर मीटर क्यूब में, सॉरी, if the density was in kilogram per meter cube and the volume was given in centimeter cube, ठीक है? You would have to either convert this into gram per centimeter cube, ठीक है? Or this to meter per cube, right? Whenever you're applying the formula, make sure the SI units are same, ठीक है? Because your answers won't be accurate then. ठीक है? I hope it makes sense. Since यहाँ पे सारे units same हैं, तो you can just put in the values and get the answers in grams, right? So therefore, the mass is going to be 9 times 5, right? So 5 times that is 45 grams, right? That is answer for first part. I hope it is same for everyone, right? So let me insert, yeah, that's good. Let me insert a blank slide. So we are now doing part B, right? So a density remains same of a material, right? Copper की अगर density 9 gram per centimeter cube दी भी है, so it will remain same for every copper material, right? Only उसकी mass and volume will be varying. The density remains same, right? So now your density आपको पता है is 9 gram per centimeter cube, right? So in part B, now they are saying कि now the volume is, sorry, the volume we want to find out and the mass is 63 grams, right? Now they're saying कि the mass is 63 grams. You want to find the volume, right? Okay, so अब यहाँ पे देखें, गौर से देखें यहाँ पे कि you have the gram mass in grams and the density in gram per centimeter cube, right? So you don't need to convert any SI units, ठीक है? So your volume would be in now centimeter cube directly. So now recall the formula, density equals to mass upon volume. And how do you get volume subject? You just manipulate the density wala factor. So it's going to be mass upon density, right? Just put in the values. Therefore, your volume is equals to 63 grams divided by 9 centimeter cube. Sorry,
Sir, 7.
per centimeter cube. Yeah. So 7 9s are 63 होता है हमारे पास. You can see. अच्छा, how do we get volume centimeter cube में अंदर वो हम देखते हैं, ठीक है ना भाई? ये देखते हैं with the SI units. आपको दिखाता हूँ. So it's basically the volume is coming out to be 7 centimeter cube, right? Acha, now see this thing over here. If I just use the SI unit, right? So mass is given you to in grams over here. आपको density दी हुई है gram per centimeter cube, right? So it's basically as follows: gram divided by gram per centimeter cube. So when you basically have this situation, you do what? You basically convert this into multiplication sign and you reciprocate the right side, right? So it becomes gram into centimeter cube upon grams, right? This and this cancels out. So therefore, the volume is going to be in centimeter cube for this particular part. Does this part make sense?
Yes.
ठीक है, अच्छा नहीं. So ये आप कर लेगा confirm देखिए whenever solving questions. Okay. So I hope it makes sense. So now let's move on to the next section of the lecture. You have solved and you have learned the formula also. How do we measure density, right? अब आते हैं एक्सपेरिमेंटल पार्ट पे आ गए हम लोग, ठीक है। जो आपने लास्ट टाइम जब एमसीक्यूज कर रहे थे उसके अंदर ये पार्ट आ गया था, राइट? डेंसिटी वाला पार्ट, कि हाउ डू यू मेजर डेंसिटी, उसके अंदर यू हैड मेजर सिलेंडर्स इन द लास्ट क्वेश्चन, राइट? So imagine you have regularly shaped solids, right? Let's say you have a cube, right? You have a cube. It's a regular shape, right? इसकी length L है, right? Okay, so you want to find density of this particular cube. ठीक है, वो क्या होगा? So just remember how do you start basically this particular experimental setup. You want to first of all write down the formula that density equals to mass upon volume, right? So in this thing, in this formula for finding density, you need mass of this cube, you need volume of the cube, right? ओके, अब मुझे हमजा बताएगा कि हाउ कैन आई फाइंड मास, हाउ कैन आई फाइंड द मास ऑफ दिस क्यूब। इमेजिन ये मास बनी हुई है, लेट्स से मेटल की, राइट? इट्स अ मेटल क्यूब ओवर हियर। इसकी मैं मास कैसे फाइंड आउट करूंगा एक्सपेरिमेंटली? यू लर्न द मेथड टू फाइंड मास इन द लास्ट चैप्टर, राइट?
वो बैलेंस मेथड।
या, ठीक है। So we can use a lever balance or any top pen balance, ठीक है, or electronic balance to find the mass, right? To find mass using electronic balance, ठीक है। सो इससे आपकी मास आपको रिट्रीव हो गई है। यू हैव नाउ दिस थिंग ऑफ ए फॉर्मूला, राइट? अब हाउ डू यू फाइंड वॉल्यूम? इसका आंसर आई नीड फ्रॉम रुबा। हाउ डू आई फाइंड वॉल्यूम ऑफ दिस क्यूब, रुबा?
We'll find volume by mass upon density.
मास अपॉन,
Volume equals to mass upon density.
मास अपॉन डेंसिटी। ओके, ओके, ठीक है, गुड, गुड, ठीक है। लेकिन डेंसिटी पता नहीं ना आपको।
Sir, can't you just length cubed?
या रुबा, बट डेंसिटी हमें फाइंड आउट करनी है ना। हमें पता नहीं डेंसिटी क्या है, आई डोंट नो कि कौन से मेटल से बना
In
है।
volume, we can use measuring cylinders.
ना, इट्स अ रेगुलर शेप क्यूब। वी कैन यूज मेजरिंग सिलेंडर, बट वो इस्तेमाल जब होता है जब इट इज इरेगुलरली शेप, राइट? इट इज अ रेगुलरली शेप। एज रयान सेड कि सर यू कैन फाइंड वॉल्यूम ऑफ दिस क्यूब बाय यूजिंग मैथमेटिक्स, राइट? बाय यूजिंग मैथमेटिक्स, बिकॉज इसका फॉर्मूला हमारे पास अवेलेबल होता है, राइट? एंड हाउ डू यू फाइंड अ वॉल्यूम ऑफ अ क्यूब? दैट इज लेंथ इंटू लेंथ इंटू लेंथ, राइट? दैट इज एल क्यूब। सो यूजिंग दिस फॉर्मूला यू कैन फाइंड द वॉल्यूम ऑल्सो। सो आपके पास मास भी है, आपके पास वॉल्यूम भी है। You can simply find the volume of density of this cube by applying density equals to mass upon volume, ठीक है? And that will give you answer, right? Either in gram per centimeter cube में आपका आंसर आएगा depending upon your units, or it would be in kilogram per meter cube. Does this make sense? Give me a thumbs up if
यस।
it makes sense. Okay, it makes sense to Mashal, Ruba, and Ryan को समझ आ गया, हमजा को भी समझ आ गया। Okay, good, good job, ठीक है। अब what if I say कि I have a irregularly shaped object, ठीक है, solid है, as Rupa said, yes sir, we can use music cylinder, right? Let's imagine I have this now, ठीक है, it's a stone, let's say something else like this, ठीक है, it's irregularly shaped stone, ठीक है, it's a stone which I found on, let's say, seashore, right? And मुझे इसकी ना वॉल्यूम निकालनी है, इसकी डेंसिटी निकालनी है कि इसकी डेंसिटी कितनी है, ठीक है। So again, I would start from step number one, that is the formula, right? The formula of density is mass upon volume, ठीक है। So to find density, I need to find basically mass, ठीक है। I need to find mass and volume experimentally, right? And volume experimentally. Okay. So how can I find mass of this object, Ruba?
And we can use a measuring cylinder. First, we
Mass,
can
not the
measure the mass of the measuring cylinder. Then we can add the stone into the measuring cylinder, and then we can minus the cylinder's mass with the mass that we have, with the final mass that we have gotten, and then we'll find the mass of the stone.
Okay, so that is also correct. But what is the simplest way to measure mass of a stone? Yes, रुबा इज सेइंग बेसिकली दिस राइट। रुबा कह रही है कि हमारे पास मेजर सिलेंडर है, ठीक है, ये एम्प्टी है, तो मैंने एम्प्टी मेजर सिलेंडर की मास मेजर कर ली, ठीक है, एम्प्टी मेजर सिलेंडर एम सी बोल रहा हूँ, ठीक है, मेजर सिलेंडर, इसकी मैंने मास मेजर कर ली, दैट इज M1 राइट। फिर मैंने क्या करा, मैंने फिर इसको, इसके अंदर मैंने स्टोन डाला, एंड आई यूज द इलेक्ट्रॉनिक बैलेंस टू बेसिकली फाइंड आउट द मास ऑफ द स्टोन प्लस दिस पर्टिकुलर सिलेंडर, सो मेरी मास टू आ गई। सो वो कह रही है कि मास ऑफ स्टोन क्या होगी मेरे पास, मास ऑफ स्टोन विल बी मास ऑफ the cylinder plus stone, that is M2 minus the empty cylinder, so that is going to be mass of stone. That is correct, but that is pretty lengthy, right? Why can't I try to use find the mass of stone using electronic balance? Won't that be simple, Ruba?
Yes, yes.
ठीक है, yeah, that is also correct, ठीक है। So how, अच्छा, now I
Sir,
want to,
can we measure? No, no, leave it.
can you measure?
Nothing.
Okay, no worries, ठीक है। So now I want to find volume, right? अब मैं वॉल्यूम कैसे निकालूं, उसका तो मेरे पास कुछ फॉर्मूला नहीं है, इट्स irregularly shaped object. How can I find volume now? Yes, Ram.
Sir, you put water in a measuring cylinder
Yes.
and then measure the volume of the measuring, I mean water, and then put the irregularly shaped object, and then the volume you get after that, you subtract the old volume from the new one.
Okay, good. ठीक है, so if we can find the volume of stone using water displacement method, right? Water displacement method, ठीक है। अब ये होता क्या है, तो रायन ने आपको बताया है अभी, ठीक है। That is as follows. If I just add a slide, so let's imagine this, you have a measuring cylinder, right? You have a measuring cylinder, ठीक है, एंड इसके अंदर आपने कुछ नोन वॉल्यूम ऑफ वाटर पुट कर दिया, यू हैव अ नोन वॉल्यूम ऑफ वाटर हियर, ठीक है। मेजरिंग सिलेंडर क्या होता है, बेसिकली इफ यू जस्ट रिकॉल, मेजरिंग सिलेंडर मेजरिंग सिलेंडर इज यूज टू मेजर वॉल्यूम, ठीक है। सो आपने जो वाटर पुट करा होगा इन दिस पर्टिकुलर इंस्ट्रूमेंट, so it has labeling marked over here in that, ठीक है, सेंटीमीटर क्यूब में होता है इसका स्केल। लेट्स से you have V1, right? V1 centimeter cube. Now you did what? You had the same measuring cylinder, right? अब आपने क्या करा, अब आपने करा है ये कि आपने उसके अंदर डाल दिया स्टोन, राइट, द irregular shaped stone, for which you want to find the volume, right? So you basically used a thread to basically put down this irregularly shaped object, ठीक है, ये इस threads का round है। अब now the volume was initially V1, right? Now it has become V2, right? Let me tell you what, guys, what is V1. V1 is just the volume of stone. Sorry, not stone. Volume of water. What is V2? V2 is the volume of water plus volume of stone, right? So if I write down the equation now, therefore, your V2 is V of 1, okay, that was volume of water plus volume of stone, right? So if I want to find volume of stone, I will send this thing over there, right? So volume of stone is basically what? It's just the difference between the two values. And it should make sense, right? जितना water rise हुआ है, ठीक है, that is basically to the volume of stone, right? Does that make sense? Does that make sense? Okay, I hope it makes sense, right? Okay, so now you have everything over here. You just need to do what? You just need to apply the formula, right? So the last step is going to be as follows. Fifth step, right? The fifth step is going to be apply the formula, right? apply the formula. And what is the formula? Which have the density of stone is going to be equals to what? The mass of stone which you have measured using electronic balance divided by the volume of stone which you have measured using the water displacement method. And that is going to be N, either gram per centimeter cube depending upon your rating scales, or it is going to be N kilogram per meter cube, right? I hope it makes sense. We have just the last two slides left because I have class in 15 minutes, so I need to pause over here. Okay. So any questions till now? You can ask away.
Oh,
Debating. Okay. We have just
no question.
two methods to be left. How do you measure volume of liquids? Sorry, density of liquids and air. Okay. So I'm gonna send a PDF of homework questions that is due to be basically done before the next class. That will be on inshallah Friday. अच्छा, जो क्लास की रिकॉर्डिंग थी मैं अपलोड कर दूंगा, तो मैं आपको लिंक भेज दूंगा। उसके अंदर से हमने ना पेपर 2 क्वेश्चंस किए हैं मास एंड वेट के ना, तो वो आप देख लीजिएगा बिफोर द नेक्स्ट क्लास। यू वुड हैव अ टेस्ट इंशाल्लाह ताला ऑन मोस्ट प्रोबेबली ऑन संडे, ठीक है, फॉर डेंसिटी मास एंड वेट। ओके, मेक सेंस? इफ इट ऑल मेक सेंस, give me a thumbs up.